Welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars daily. You are watching Into the Cloud, a programmatic approach to go deeper into strategic themes for cloud business. My name is Scott Ellis, and today we're going to be talking about protecting sensitive data on Google Cloud Platform. You can ask questions anytime in the platform, and we have Googlers on standby to answer them. Let's get started. So we're going to cover how to take charge of your data, protecting sensitive data on the Google Cloud Platform. In this session, we'll share the latest advancements on the Google Data Loss Prevention, or DLP, infrastructure, and walk you through a few example scenarios and demos. First, we're going to give an overview of what Cloud DLP is. Then we'll walk into a scenario and some live demos. So before we get started, let's just kind of level set about what we're going to be talking about today. In this animation, we're showing a kind of a live real stream typing of some sensitive information. And you can imagine this coming in a chat application or some real-time customer support scenario. And as you see in the top box, this customer is just typing in a lot of sensitive data, information in unstructured form. And so when we talk about protecting sensitive information, this is the kind of information we're talking about. Personally identifiable information, or PII, things like social security numbers, credit card numbers, dates of birth, and things like that. And in the bottom box, we're just showing a sample of some of our different ways to protect this data. We're classifying it, and we're masking it, or tokenizing it. And so today we're going to cover how we can apply a lot of these tools in a couple different scenarios. But first, why would you use this, and kind of who would use this? A lot of different personas at your company can leverage the cloud data loss prevention infrastructure. This may be somebody who is a developer or engineer who's writing code. This could be somebody who is a data scientist or data engineer who's working with data or running analytics on data, or somebody in the security, privacy, or compliance operations, where they may be concerned about governance of their data, where that data is being stored, exposed, and used. And again, where this can help is to help with things like compliance, audit reports, to help ultimately to protect your users. Again, this data is information that you have or you're collecting about your end users, and ultimately you want to help protect it and make sure that data is used properly. And overall, just to help reduce your risk. So even when you're using this data for an approved business purpose, you want to make sure that you are reducing the risk of using that data or exposing that data. So first, let's go in and give an overview of Cloud DLP. There are three core capabilities that Cloud DLP offers. We're going to cover those in a little bit of detail here. The first one is discovery and classification of data. So out of the box, Cloud DLP has about 100 built-in classifiers. This includes a lot of different types of PII, like names, dates, passport, credit card numbers, phone numbers, and a lot more. As you can see here, we've kind of given a sample of the different identifiers in all the different countries where we have specific unique country identifiers. This would be like a national identifier for that country. We also have a lot of global identifiers, which are things like email, phone number, credit card number that apply across the globe. In addition to these built-in types, we also have a set of custom, you can also build custom classifiers, and there's a set of different types you can use, from dictionaries to pattern-based, like regular expressions, and you can also enhance these with context, exclusion, and detection rules. We'll show a little bit of that later on. The next core capability is what we call de-identification, sometimes referred to as data masking. And this is a set of transformation tools that allow you to actually take the data and transform it to reduce the risk. And in this simple animation that you're seeing here, we've got a table of data, and we're applying different transformations across different columns in this table. In that first column, we're applying something called format preserving encryption to take that identifier and produce a surrogate or a token that has the same structure and length and format. In the second column, we're doing something called generalization or bucketing. We're taking a distinguishing value in that job title column and replacing it with a less distinguishing value. So something like senior engineer gets replaced with engineer. In that third column, we're doing a simple partial mask out of a phone number. In that fourth column, we're actually combining that discovery and classification capability with our masking capability. And what we're doing is we're searching inside the comment field to find the sensitive data, and when we find it, we mask only that bit of data. So you see the email address or phone number or social security number are actually masked, but the rest of the text is left intact. And so this is kind of a powerful thing that you can do to combine those two capabilities. It also works on images. So what we're showing here is kind of a mock example of a loan application. We've got some sensitive data on the original image. We've fed that image, in this case it was a JPEG, into our system to identify the data using some of our powerful optical character recognition to identify the characters. We then use DLP to identify the actual sensitive data, and then we actually draw the boxes and mask the information to produce that image on the right. The third core capability that DLP provides is what we call re-identification risk analysis. What this is actually looking at large structured data sets to identify statistical outliers in the data that could increase the risk of re-identification for that data set. So we employ popular risk metrics like k-anonymity, L-diversity, k-map, and delta presence to do this. Now we're not going to go in depth on this today, but I did want to show you one example. So imagine again you have a data set, and let's say in that data set you have something like that job title column that we referred to earlier. Now job title is not normally considered PII. It's not something that you would look for and necessarily mask all the time. It's something that can be more of a what we call a quasi-identifier, something that sometimes is identifying, sometimes is not. So if you look at this simple table here, we've got a column of job titles, and even in just these 5 rows, we see something that could be concerning here. This value CEO of Google is a job title that is held by very few people. And if you had data published where that job title was included, most people could identify this person for a couple reasons. One, it's kind of public knowledge. And 2, it's a unique value shared by just very few people or just one person depending on the time. Whereas the software engineer value is shared by a lot of people. In this example, there's 4 people that share it. But again, if you were publishing data and had a job title of software engineer, it would generally be a lower risk. So in this case, how do we identify these outliers? That's what we use our re-identification risk analysis tools to do, is to scan this data, identify these high-risk outliers, and then you would either remove those rows or use something like that bucketing or generalization that we showed. Maybe you take CEO of Google and convert it into something like executive. And again, where executive has multiple people in it. Great, so that's kind of the overview of Cloud DLP and how it can help you. Next, we're going to go into an example scenario and actually show some of this in action. And we're going to start off by talking about data discovery. So let's meet Angie. So Angie is a data compliance officer for a large online retailer, and they serve customers across the globe. Angie oversees how data is collected, shared, and used across all departments. Now, most of their data is sitting in cloud storage and BigQuery. And what Angie wants to do is ensure that this data is properly protected, that only the right people are seeing it, it's not overexposed, and also generate a report for management and auditors, something that's visual, something that they can see and use without having to dive into a lot of the details. And how is Angie going to do this with Cloud DLP? Well, first, she's going to create an inspection template, and that's going to capture all the sensitive data that Angie cares about. Next, she's going to start an inspection scan to classify this data in cloud storage. And then we're going to set that to run on a regular basis, something like once a week. And then last, she's going to create a simple audit report of the findings. And for that, we're going to use Data Studio. Now, for this demo, we're going to mostly use our Cloud Data Loss Prevention UI, or user interface. This is available in Cloud Console. And it's something you can go and just simply go to, click, and do a lot of the tasks that we're going to do. Now, Cloud DLP also offers a very powerful API that allows you to do things like real-time content inspection, real-time de-identification or masking or tokenization. And you can also use it to create, manage, and run jobs or edit templates and a lot more. But today we're going to use the UI. So the first thing that we're going to do is we're going to create that inspection template. So in the UI, we would simply go over to Create, click on Template. And I'm going to walk you through the steps to create a template here. The first thing is really to give the template a name. This is something that you'll reference when you use it. Maybe a description, kind of a human readable description so everyone can understand what this is. And then the first step is to pick the built-in info types that we want to use. In this case, Angie has selected several different types of PII that are, again, built in. Simply select them, and DLP provides these detectors. The next step is to add in some custom types. So Angie's company has a couple different things that they want to detect. And they can use the power of regular expressions and pattern matching. They can also build dictionaries, and they can be sizes of dozens of entries to thousands. We also have support for very large dictionaries, which are into the millions. In this example, Angie has created a couple different custom types. The first one is a large dictionary that is pulling from a list of all their European user IDs, as well as their US user IDs. And this allows Angie, when she's searching for data, to see if the finding actually fits into one of those two categories, so she can understand European users versus US users based on their internal user ID. And she's also created this custom type she called custom design doc. And what this is a regular expression that is looking for a string pattern that is on all of their design docs, just to make sure that one of their internal design intellectual property hasn't been exposed too much. The next step in the template is to create some inspection rules. And what these do is allow you to take the inspection and tune it. You can do things like create exclusion rules to reduce unwanted findings, or hot word rules to fine-tune the results based on context. In this case, we're going to create a simple exclusion rule. And what we're doing is we want to use that built-in email address detector, but we want to exclude out all employee email addresses. In this case, Angie's company domain is testdlp.com, and she just wants to exclude any email that has that domain. And this way, she's not finding data about her employees in the scan, but would only find emails that don't match her employees. Again, a very simple exclusion rule. Apply this to email address, and that's it. Great. So now that we have the inspection template built, let's actually jump out and see this in action. So what we're going to do today is we're going to scan. So I switched over to our Cloud Console, and this is a listing of the company data that's sitting in cloud storage. There's a lot of departments represented here, from finance to marketing to research. And what we're going to do is create a job to scan this bucket. So I'm going to just go over here to security and then data loss prevention. This is going to jump into our user interface for DLP. First thing I see here is a list of the jobs that I've already ran. I can also see job triggers, which are ongoing repeating jobs, or I can edit templates. So if I go here, we see that we have that template that we just talked about that has these built-in info types that we selected, as well as some of these custom types that we defined, and that inspection rule that we just created to exclude the company email addresses from the standard email address detection. Great. So we're going to use this template. We're going to go and create a simple inspection job to scan that cloud storage bucket. The first thing I'm going to do is I'm going to create a job ID. I'm then going to select that we're going to scan cloud storage. And I'm going to just do a simple selection of that bucket that we want to scan, which is called company data. Now, when you're doing a scan in cloud storage, the data there can be huge. So we have a lot of features and capabilities to do sampling. What this means is we can randomly select a set of files that are in that bucket. And then once we find a file and we're scanning it, we can also randomly select a part of that file or a certain number of bytes that we scan inside that file. Now for this scan, we're going to scan everything. So I'm just going to set the sampling to 100% and then turn off the object sampling here, so we scan the entire thing. Click continue here. Now we've already created this template, so I'm simply going to select the template here and move on from detection into the next section, which is actions. Now actions are where a lot of the power of DLP can be realized. So we have a couple actions that we'll go through here. The first one is save to BigQuery. What this allows you to do is save the detailed findings of the scan into your own BigQuery table so that you can use it for more powerful analytics, create an audit report, or export that to other systems. You can also do things like emit a pub sub notification when the job is done, publish to Cloud Security Command Center if that is something that you're using or your company's using, or do a notification by email. Now the next section here is the schedule. Now we had talked about wanting to run this on a periodic time basis. So I'm going to set this up to run every 7 days. And what that means is it's going to basically kick this job off every 7 days. I'm also going to check the box to limit scans to only new content. What that means is the first time it runs, it's going to scan everything. and then when it runs 7 days later, it's only going to scan data that changed within that 7 days. And again, this is really helpful when I'm monitoring data or want to set up this kind of ongoing audit report. All done, and I will just click create. So what that's going to do is kick off, oops, let me see here. It looks like I used the same name here to give it a unique name. And let's create that again. OK, so now we've created this job. It shows me the configuration here, and it's going to trigger and run every 7 days. Now I can also go here and just run it right now and kick this job off. But before this talk, we actually went ahead and ran this job over the weekend. And so let's go ahead and jump into that trigger that we already created and kind of go over the results here. So as you see, this was the trigger we created. It's had one job run. The whole entire company bucket was about 10 gigabytes of data. But even in just that amount of data, we found over 4.5 million findings. So a lot of findings there. We want to dive in and kind of understand those and see what they are. First thing we're going to do is jump into the job itself. And as you see here, we're going to get a nice high-level summary of the details. These are all the different types and the findings that were found in that job. We see social security numbers, credit card numbers. We also see some hits for that EU and US user ID. And it looks like we found at least one instance of our custom design doc detector that was kind of looking for those evidence of a design doc sitting in cloud storage. So this is a great summary detail, but I want to dive in and see a little bit more. I want to know what files had these. I'm going to run some analytics. So right from here, we can jump and view these findings in BigQuery. What this is going to do is it's going to open up those detailed findings directly in BigQuery, so you can start to write any SQL statement against this. You can export this data. You can do a lot. So just to start, I'm going to run a simple query that we have here, just to kind of show you what this looks like. OK, so I've run this query. It's simply selected the info type name, the likelihood of that finding, the certainty, as well as where we found it. So as you see in the results, we've got a very powerful set of results here that tells me every instance where we found a social security number, what the certainty was, and exactly what file it was in. It looks like we've got some production data or a copy of it that was put in this folder, and maybe that's something that we need to look into. Now, one of the other options that you can turn on when you're saving findings to BigQuery is something called include quote. Now, include quote allows you to run even deeper analytics to actually find data tied to a particular value. And this can really help you, especially when you're doing exhaustive scans, to do things like data deletion requests or data access requests, so you know exactly where data is about a particular individual. So just to show that really quickly here, now this option is off by default, but for this scan I had turned it on. So I'm going to run a very similar query to the one we just ran, but I'm going to add a where clause in there that says, go find any time you found an email address that matched this particular customer, which is jacksmith@example.org. And as you see here, the results, I have 11 different results here. These are files that contain that email address. So if I needed to understand where that data was for Jack Smith, I now know where to look. So that's a very, very powerful feature that you can optionally turn on. Now, if we go back to the results here, so this summary report is helpful. Angie could take this and just show it directly to her management or auditors, but they may want to get a little bit more detail than this. So again, we could go into BigQuery and show a SQL statement, but what we're actually going to do is we're going to jump into BigQuery, but instead of writing a SQL statement, what we're going to do is I'm going to click over here, and I'm going to explore this data in Data Studio. So what this is going to do is it's going to load this information into kind of a more point-and-click visual experience. So what I'm going to do is I'm going to kind of, instead of writing those SQL statements, I'm just going to create a very quick visual report here where we can see some of this information in action. So what I've done here is I've simply added the info type name. I'm also going to add another thing here, which will give us the file path and the record count here. So just with a few clicks of a button, and I'm just going to resize this a little bit here, what we've seen here is how easy it is to create a report that allows me to see this data again, without having to write SQL statements in a little bit more visual fashion. I can also just very quickly create some filters up here. Again, this is just the power of Data Studio, but I'm building this directly off of the Cloud DLP findings that came straight after the job. So now we see here a similar view that we saw in SQL, but it's something more visual that I can use and interact with. So for example, if I want to go up here and I want to limit to only where I found credit card numbers, I can simply click here, apply that filter, and now I'm going to narrow in on the file that had those credit card number findings. Now, as you know, credit card numbers being stored in raw text is usually a problematic thing to look into. So it looks like we have a file here that is our chat logs that are in the research folder. Maybe somebody was trying to build an analytical pipeline off this. And in those chat logs, it could be that customers entered in sensitive data like their credit card number in that unstructured text, and it got stored in our chat logs. And then now it's exposed through this file, and we want to prevent that. So that's something we're going to look into in a little bit. But first, I wanted to jump in and also look at that other type. We had a finding for our design doc. So I'm going to filter on that one and see where we found that here. OK, so it looks like there was a file here called screen grab sitting in the finance folder. So why don't we go over here and let's look at that file and see what it looks like here. So I'm just going to go into cloud storage. We're going to browse into that finance folder called external share. And there is that file there called screen grab 123. So if I pull this up, it looks like somebody took a screenshot of a design doc. So in our search, what happened here is we actually looked at this file, ran our OCR technology, and then identified that design doc pattern that we created the custom detector for, and detected it in this screenshot. So that's great. So that's something that we can go and remediate, maybe by simply removing the file or changing the access control in it. But we want to go back here first. And so again, this is a visual audit report that we built. I was able to jump in and see the credit card numbers that we found. I can very easily drill down. But if I'm going to create an audit report for management and for auditors, you probably want to build that maybe a little bit more robustly, store it, and share it. So I'm in something called the Data Explorer part of Data Studio, but I can very easily jump into the full Data Studio and create a bigger audit report. So I'm just going to go ahead and load the report that Angie built. Very similar to that Data Studio Explorer, but in this case, it's using the full Data Studio. We see here a listing here of all the findings. We can do the drill down just like we did in the Explorer. We can also go in here and search by file name. I'm going to just limit it to that one chat file. And as we see here, we've opened that chat file, and we see findings, both the credit card number as well as all the other findings for that chat file that exist. So this is a really powerful, robust audit report that's ready to go. It'll update as soon as new data enters into the scan. It'll show up. And it's very easy, just like if you're using Docs or sharing a document, you simply go in here and share this, and she can share it with management or internal auditors, whatever she needs to do. Great. So again, the next steps here are we found some sensitive information, and we want to figure out how to reduce the risk of that data being in our system. Now, when we ran that audit report, one of the things we found, again, was this folder that looks like it contains a lot of our chat logs. And those chat logs, it looks like, have some credit card numbers, social security numbers, and some other sensitive data in them. So what we really want to do is take action from that audit report and go try to remediate this. So what we want to do here is we want to protect that chat data, but also we want to make sure that our data analysts can use it. So what Angie's going to do is step one is she's going to restrict access to that raw data that's sitting in cloud storage, and do that using our identity and access management. Simply make sure that it is not widely exposed. And step two, she's going to go and create a pipeline that will de-identify and ingest this data into BigQuery. And this is important because this data is coming in constantly. These customer support chats are updated maybe hourly, maybe daily, maybe weekly. But as that data comes in, we want to be able to analyze it. So Angie's going to create a simple pipeline that will take that raw data, de-identify it, and ingest it into BigQuery. So it's an automated, repeatable process. And what we see here on the right is sort of what the output is that we want to get to. We want to obfuscate that user ID. In this case, we're going to tokenize it using one of our cryptographic methods. And then in that data column where we actually see the chat log, we just want to go in and remove any PII that we don't expect to be there. So how is Angie going to do this? Well, she's going to use our new click-to-deploy DLP data flow pipeline and use the data flow UI to do this. What she's going to do is configure that to tokenize that data and to mask all the unstructured data. So as we see here, we're going to click on Create a Job from Data Flow Template, and we're going to select the data masking tokenization using Cloud DLP from GCS to BigQuery. Again, this is going to allow us to take that data automatically as it hits cloud storage, ingest it into BigQuery, and de-identify it. So this means that Angie can get the huge scale and the simple deployment of this robust pipeline, all from just a few clicks from the Dataflow UI. So when you create that job, she's got to fill out just a couple bits of information. Give it a name at first, but then down here where you see the red circle, she's got to give a path where this file is going to land in GCS. That's really simple. She's got to give it a destination BigQuery data set where we want to write the data. And that's, again, where her data analyst will have access to. And then she's going to use a DLP de-identification template to define exactly what happens with that file. So again, just a few bits of information to fill out, clicks Run Job, and now this pipeline is running and ready to take that data as it lands in GCS. Great, so let's just quickly see this in action. First, I'm just going to browse over to Dataflow, and we're going to show you how easy it is to launch that template. Again, if you don't know how to use Dataflow, you don't have to understand all the intricacies of it. You can simply click here, create a job, select that template, fill out just a few bits of information, and click Run Job. It's that simple. Now, once it's running, the Dataflow job, it's a streaming input. It's going to be looking at that cloud storage bucket and looking for files that land there, and then automatically process them. This is just kind of the summary page of the Dataflow pipeline. As you see, in this workflow, we've got a tokenization step, and we've got a write to BigQuery step. This is great. So to actually use it, I'm going to navigate over here to cloud storage. I'm going to navigate to that folder that we created for our chat logs. Now, we've already run 4 different runs through this system. And again, these are relatively small files just for the demo. But I'm going to go ahead and upload a 5th file here. This is, let's say, the next run of the file. And so as you see, I uploaded the file into cloud storage. Now, however it gets here, it doesn't really matter. I've simply gone and browsed, clicked, and uploaded this file. But that file will be picked up, processed, and run into BigQuery. So let's just go and see what that looks like over here. I'm going to navigate to that webinar data set that we created. And as we see, the files that I dropped in there earlier are all there. And let's just actually query one of these tables and get a sense for what we're doing here. So I'm just going to do a select star. And because we have multiple data sets coming in, I'm just going to do a star on the actual data sets. And let's run and just see what this looks like. Great. So as you see, just these sample chats, we see that the user ID has been tokenized. The data in the data 1 column, which is our unstructured data, has actually been inspected and filtered. So we see things like credit card numbers and email addresses have been redacted and replaced with the type. And that's great. But the real power of using this method and using something like tokenization is that your analyst can still use the data. So we could have simply removed all these things and left them, let's say, without the user ID column at all. And that would have been hard for them to run certain analysis. So what I'm going to do here is I'm actually going to create a little bit more complex statement here. And what we're going to do is we're actually going to count all of the support chat messages that we have and group by user. So I'm going to group by the user ID here. And then I'm just going to simply order by the count in reverse order. Let's see if I got this right. Great. So by running this statement, what we're really doing is we're saying, go to that user ID, group by it, and count the number of messages that we see here. And as we see, we've got 2 users that have a count of like 37, meaning they've had 37 messages to support, another one that has 36 messages, and then a lot that have 4. Now, if I add this user ID in here, we're going to see that user ID next to it. So what we've shown here is that even though I don't have access to the raw user ID, I still kept the referential integrity and statistical properties of that data. So my statement, my SQL statement here, had I run this on the raw data, I would have gotten the same result. But in this case, I've been able to run that and not reveal that raw user ID, and also not reveal any of the sensitive data in that unstructured data 1 column. So again, these tokens are very powerful, allow you to protect the data while in use, and still retain that balance between data privacy risk as well as data utility. Now that we have that set up, what that means is that Angie and her company can leave that pipeline running. As data gets dropped into that folder, it just automatically will update and show up there. So we focused a lot on scanning in cloud storage, but I just wanted to cover that we also support scanning in BigQuery. So we can inspect data in BigQuery. This can be done directly from our UI, or from this recently launched Scan with DLP button that you will see directly in the BigQuery UI. So if you're navigating, looking at a table, and you want to inspect that table, you simply go over to the Export dropdown, click on the Scan with DLP button, and that will pre-fill all the information for you. You can confirm it and run the scan. Again, just to make it easy to access where you are with your data. That's all that we have for today. I want to thank you again for joining this. A couple quick notes here. First is, with Cloud DLP, if when you're ready to use it, it's simple. You just simply turn it on. It automatically scales for you. There's no complex deployment to manage, no VMs to manage, no patches or updates to manage. It's simply a service you access either through API or through the UI. And again, just want to note it does support real-time and batch workloads. And that's it for the presentation portion of this talk. So please stay tuned for frequently asked questions. We will be back in less than a minute. Great. So we're going to cover some of our frequently asked questions here. And so the first one on there is, can you create custom detectors? And the answer is yes. Let me go ahead and jump back here, and I'll kind of walk through that again in a little bit more detail. So again, out of the box, there are over 100 built-in detectors. But you do have the capability to create custom detectors. And what these are is basically where maybe you have your own internal ID. Maybe you're a healthcare company and you've got something like a medical record number or a plan benefit number, and it's just not well defined in the industry. And this is something where you have to go in and, let's say, define a pattern or a list. So you can basically create a pattern-based one, which would be something like a regular expression. Or if you need to, you can also use our custom dictionaries to find these kind of identifiers. So for example, let's say you just have a huge list of identifiers and they're very hard to define as a pattern. Then you can just simply point to a cloud storage file or a BigQuery table of those identifiers and use those as part of your DLP search. And that is super powerful. The other thing you can do is enhance that with context rules. So let's say that you have some sort of identifier, but you only want it to show up in high certainty when it's near something like the word user ID or MRN or patient ID. You can definitely do that. And so again, that customization is kind of the first step to finding the identifiers that you need. And let's go to the next question. Okay, so how do you adjust certainty and deal with false positives? So false positives are a common concern whenever you're doing sort of data discovery or kind of data classification. And there's kind of two types here. There's false positives where it's actually a finding that isn't what it's supposed to be. And then there's also something else, which is maybe just unwanted findings. It's actually a finding. So for example, maybe we actually find an email address and it is a valid email address, but again, it's just not one that you care about. So you can augment the findings as well to adjust certainty. There's two ways you do that. Out of the box, you can pick from 5 buckets of certainty. We call them likelihood, going from like very unlikely all the way to very likely. And this is just sort of a way to kind of get the trade-off between precision and recall or findings and misses. So you can adjust that certainty. You can then use our exclusion rules to go in and actually tune specific results. So maybe there's a particular name, particular email, phone number, or whole set of values that you just don't want to find. They could be things that are public about your company, not sensitive details, or again, maybe it's your employees and not your end users. So you can definitely go in and create these inspection rules to do what we call an exclusion rule to exclude those out. And that's how you can help tune the data to reduce kind of this unwanted findings. And then ultimately, when you get the detailed findings, you can also write any SQL statement to evaluate that data and combine it. So you use the full power of SQL to understand those findings. Okay, so next question. Can I use this data, or can I use this on data in real time? It's a great question, and we touched on it briefly with that animation at the beginning, but yes, you can use this on data in real time. And what that means is, let's say you have some sort of application. A common example of this might be some sort of like a interactive support chat app, or it could just be a form that's collecting data from your customers, like a feedback form. They go in and submit data, click submit, and that data comes into your system. And what you want to do is you actually want to scan, inspect, and maybe even redact and mask that data in real time. So before it's shown to somebody, before it's stored in your system or persisted to disk, and you absolutely can do that. You would normally do this through our API. It includes what we call content methods. And these are methods that run, again, in real time. You send the information into the API call. You get a response back either with findings that allow you to triage or adjust that data based on the findings, or you can get a redacted payload back. And again, what that means is that your actual data will come back, but the sensitive information will be redacted based on the configuration that you set. And this is built to run in a real-time environment. The API calls can be RESTful calls. We also have client libraries in several languages. And it's a synchronous call, again, so that data comes in, your response that you get back right away in real time. Okay, looks like there's one more question on here. The question about the data, can you export this data to another system? And I think what you mean here is the findings data. So yes, you can. As you saw when we were kind of going through the demo, we jumped into BigQuery to analyze that data. And I was running SQL statements with just one click of a button. I was into BigQuery, writing SQL statements, or actually going into Data Studio and visualizing that data. So it's very easy to export the data into BigQuery and into Data Studio with just a few clicks of a button. But maybe you want to pull this data into your own system. Maybe you have your own security event information management system, or you have some other just analytical signal system that you want to pipe this data into. And so the answer is yes. Because this data is written into BigQuery, and it's a BigQuery table that you own and you manage and you control, you can take that information and you can just export it to any other system. Basically just do a BigQuery export or run some pipeline that can read straight from BigQuery and bring it into virtually anywhere. And that is the last question that we have on here. And so with that, thank you for tuning in. Please visit Cloud OnAir for more content from our Google Cloud experts. Thank you again.